Hey everybody, welcome back to Young Engineers of Today. We're not going to be doing any coding on the Pi yet. We're actually going to continue with CodeCombat today. Although next week, who knows? The future can hold anything. Aha. But yeah, so that's what we're going to be working on today. We're going to get through some more. I'm going to spend some time reviewing what you guys did on Monday, mostly because my account is an instructor account. I only have one email, and so I can't actually navigate off of the instructor page in order to be able to run through the levels with you guys. So I'm running through them in an anonymous account. So that'll be a nice way to at least do the review and stuff like that. So without any further ado, let's spend some time reviewing what you guys went over on Monday. If I remember correctly, you guys got up to loops. So it's possible, let's see here, that's only, let's see how far that is. I believe that's the second Kith Maze. Anyway, it's not too terribly far. So let's jump into it. So we're going to start out with the Dungeons of Kithgard, which is just going to show you some basic syntax, and we're going to be Captain Anya Weston, because why not? And we're going to do Python, because that's what you're going to be doing on the Raspberry Pi. We already knew all these things. Nothing particularly mind-blowing there. Equip the shoes, hit play. The shoes allow her to walk. They basically give her the commands for walking left, right, up, and down. So, as you can see, okay, yeah, I got it. I got it. As you can see, just as a reminder, our heroes are controlled by inputting syntax, commands, code commands. So we need to use the proper syntax in order to guide our hero, not only to the exit, but to grab the gem along the way. Thankfully, this is all very simple. All we have to do is walk right, and then down, and then right again. So that's simply a matter of calling our hero, and then move down, and then calling our hero one more time and saying move right again. And that's all this level requires, is just hero move right, hero move down, hero move right. Pretty straightforward. Um, and that's it. We'll get more into why we have to have the parentheses and why there's the hero dot before everything as we get further along in coding. But as it stands right now, though, just knowing that that's a thing that you do is good enough, because it requires a little bit more understanding about what's going on under the hood, which it's sort of a chicken or egg thing. I don't want to bore you guys with the why we do what we do until you understand some of the things that you can do with coding a little bit better first. So you do a little bit of both of them. As you get more comfortable with doing uh, getting familiar with the syntax, then we can start going into why you do the things that you do, so that you can start building code on your own. Once you start building code on your own, then it becomes a matter of becoming more comfortable with code and building larger and larger programs, and suddenly you're a programmer. So the belt's going to give us a little bit extra health. Nothing too crazy there, no new additional commands or anything like that. So now it wants us to collect all of the gems and not hit any of the spikes, but it is going to involve moving right. Then we're going to hero move down. Then we're going to hero move up, because obviously we're going to go right and then down, and then we're going to want to move back up. Then we're going to want to move up one more time. So hero move up. Oops. Now here's the great thing is we don't really actually have to move up, strictly speaking. We can move to the right and then up to the left. But what I'm going to do is I'm going to move up and then to the right, because it's fewer commands. And one of the things that you are going to become very familiar with if you start getting really into coding is the less you have to type, generally the happier you are. Now, that depends. Sometimes I really like typing, so I can be really like kind of weird about that. But by and large, when you start working on larger projects, you want to type less. You want to be more efficient with the typing that you do. You want to be more efficient with your calls and stuff like that, especially because as your programs get larger, you're going to have to spend more time sort of unpacking all of the code in your brain and things like that if there are more commands. So for now, let's go with the more efficient thing. Let's make sure that we're typing less. So move right, move down, move back up, move up one more time, and then move right again. And hey, look at that. We've grabbed all of the gems. Nothing crazy there. Again, this is just introducing us to the syntax, so I feel like we don't need to spend a whole lot of time covering those things. Now let's get to Shadow Guard, which is still going to be more syntax. Oh, Lord. We're still going to be Captain Anya Weston, and we're going to hit play again. Okay, so it's bugging out. All right, we're okay. Everything's okay again. So now we want to make sure that we're moving right and grabbing all these gems. However, if we move along this bottom path, the ogre will see us. So we want to make sure that we walk up and around the statue. I think this is all pretty old news at this point. Tell him to move right. Tell him to move down. And then I'm right. Boom. And that should be good enough. And look at that, move right, move up, move right, move down, and move right. And just like that, done. Again, I'm kind of going through these pretty quickly, but since they're a review at this point, these shouldn't be, oh, no. Back, close, just continue. There we go. Yeah, we can just close this. Okay. Learn the enemy's true name to defeat it. Play. So we're going to equip the sword. Now the sword is going to give us the attack method. So now some of the items are going to give you additional methods that you can then play with in order to do things. The sword gives us the ability to attack. We're going to attack Brack twice, then we're going to collect the gem and check Treg twice, and we got to make sure that we survive. So as you can see, it's pre-filled some of the commands for us. Hero move right and hero.attack Brack, hero.attack Brack. Now you'll notice that the Brack is in quotes, and the Brack is also inside of these parentheses. That's because we're somewhere in the CodeCombat code, the attack command requires a name. It needs somebody to attack. Just like when we say, hey, go give this to somebody. Like if somebody handed you I don't know, burger, and they're like, go give this. Okay. Who do I give this to? Who do you want me to give this burger to? You know, you need a little bit more information than that. And code is even more explicit than that, because sometimes, you know, somebody's sitting over there and they're super hungry, and the person says, here, give this burger. And you can infer based on context, oh, probably to that hungry person. Code is much more explicit than that. So we're always going to need to specify something. So in this case, we're telling it explicitly, hey, we want to attack Brack. So the attack command is always going to need somebody to attack. Anyway, with that in mind, after we're done with attacking Brack twice, we're going to move right, and then we're going to Treg. Now you'll notice that I accidentally typed a lowercase t, and then I was very quick to fix that and make it an uppercase t. Again, computers are very explicit. In fact, the lesson that you're going to be learning throughout all of this, as you're getting more comfortable with coding and everything like that, is that computers are dumb. And you've heard me say it before if you've been in this class before. You've maybe heard other people say it before, but computers are dumb. I don't mean that to disparage them. I mean that in that they don't have complex reasoning and abstract, you know, sort of the ability to connect abstract thoughts together in order to come to a conclusion like humans can. They don't have the ability to infer. They don't have the ability to recognize context. So when we say that we want to attack Treg, Notice how treg is a capital T. All the computer's doing is comparing letters to one another. Each letter has a numerical value inside the computer, and a lowercase letter has a different numerical value from an uppercase letter. So if we say treg with a lowercase t, because a lowercase t has a different numerical value from an uppercase t, it's basically going to take all of these different letters and add them together to get a value. Well, not really like that, but it's going to compare the mathematical or the numerical values of each letter one at a time. And it's going to fail in the first letter because a lowercase t is not an uppercase t. And technically, the computer is correct. A lowercase t is not an uppercase t. However, they're both still t's, and we know that as humans and with an intrinsic understanding of language. A computer doesn't know that intrinsically. So we need to make sure that we hold its hand throughout this entire process. So that's the introduction of something like a syntax error. An error with your spelling or with your grammar or something like that. That's the issue. That's where you can run into your first issue with something like that. You might have already run into your first syntax error on Monday when you were trying to say move right and maybe you had a lowercase r and the computer didn't know what you were talking about. Well, you knew what you were talking about. You wanted to move right. However, again, the computer compares things by doing that specific letter comparison. And a lowercase r is different from an uppercase r in its little computery brain. So it's not going to know what you're talking about with that lowercase r. It's going to flip out and, everything's going to go wrong. So that's an example of a syntax error. Again, I know I'm flying through these things, but we'll get to some more of the stuff, and it'll make hopefully some more sense. So yeah, attack brack, attack treg, grab the gem, done. Let's head on to the next level. And if at any point too you say like, hey, we didn't actually go over these levels yet, just let me know so that I can slow down and start explaining the rationale behind this stuff. Because I also don't want to be like, hey, so, and then you get here and then you start doing this stuff and you're like, wait, what? So the raised sword is practice and favorable odds is practice. And sleeping on the job, I believe, is our next one, if I remember correctly. No, I believe it's the raised sword. Learn to equip yourself for combat. Hit play, yeah, Python. Oh, we have to equip. Good Lord. Okay, so we have to unlock it, confirm, and then equip it for the extra health, and now we play. Okay, so you defeat the ogres and your hero must survive, and bonus no code problems. Attack each ogre by name. Remember, each ogre takes 2 hits. So this is the same thing we were doing before. We just have to make sure that we, this is more repetition in order to get familiar with it. So I think we can probably actually just start out with an attack, a couple of attacks. And then inside of the parentheses here, I'll just fill it up with rig. Oh, I can't use that. The left arrow key is broken on my keyboard, and it's making me very sad because I just want to go back a couple, and I hear me just mashing on that. I can't. I can go forward, but I can't go back. So we'll attack rig twice and see what happens. We'll hit run, and sure enough, boom, attack rig. But she doesn't do anything else yet because we haven't told her to, so I'm just going to start typing hero.attack and hero.attack and hero.attack and hero.attack. So there, now we've got 4 additional attack commands, 2 for each orc. Now I'm going to attack Gert twice, and then I'm going to attack Ack twice. And just like that, we hit run again, and attack Rig, attack Gert, attack Ack, attack Ack. Boom, done, all 3 of them. And again, this isn't any new concept from the last level. This isn't really even any groundbreaking concepts from any of the previous levels. This is mostly just repetition so that you guys get more comfortable with Python syntax. And we're going to get a new item. It's going to be programmaticon. Boom, continue. This, I believe, yes, this is where you guys left off, was looping. So I think Mr. Dubik introduced you guys to loops on Monday. Is that correct? Maybe, possibly, potentially. Yes. Okay. So loops are pretty basic in concept. Loops just run a bit of code a specific amount of time. Now, to be clear, that specific amount of time could be forever. However, loops follow a rigid logical structure just like everything else in programming. I say that, and then you look at some programs and you go like, wow, okay, good luck with actually believing that. But like, first off, let's just do what they say here. So we're going to say hero.move left. Yeah, we're going to hit run. And sure enough, our hero is just going to move left and right over and over again. It's just going to run this loop over and over again. And in fact, this loop is going to run forever. But it's important to note, how do we know it's going to run forever? How do we know it's part of the loop? Well, let's introduce you to the first type of loop, which is the while loop. I know. Hold on to your hats. We're going down a rabbit hole, a programming rabbit hole. Let's make this super big. So while, and then something in parentheses, and then a semicolon, and then do stuff, do more stuff. This is the basic structure of a while loop in Python. We've got while, and then we got do stuff, we got do more stuff, and then we got do other stuff. Python is a white space based code. That is to say, spacing is everything. What parts of this code are a part of the loop? Does anybody know offhand? I believe in you guys. I believe you do. Yep. Yeah, you got it, Jean-Marc. They're the ones that are indented. I used a tab indent. I'll use 4 spaces because Notepad doesn't use a typical tab indent. But yeah, anything that's indented by 4 spaces, typically tab indented, especially if you're using like a Python editor. Those are going to be a part of anything after the semicolon. Anything that's not indented, like do other stuff here, is not considered a part of anything after the semicolon. That is to say, it's not considered a part of this while loop. So once the while loop is done, then we exit the while loop and we start to do other stuff. But as long as we're in the while loop, all we're doing is stuff and more stuff. So how long do we determine whether or not we're in a while loop? So we've got this one over here, which says while true. I stuck an extra P in there for some reason. While true. That's one way to do it. We can also say while x is less than 4, and then we can say x equals x plus 1. And there are easier ways to type this, but I'm expanding it all out for readability's sake. All this is saying is every time the while loop runs, we do some stuff, we do more stuff, and then we add 1 to x. So this loop is going to run as long as x, in this case our variable, is less than 4. So let's assume for a second that x equals 0. So x is going to be equal to 0. It's going to enter this loop. Is x less than 4? Is 0 less than 4? Yes, it is. Cool. Do stuff. Do more stuff. Add 1. Now x is 1. Reach the top of this loop again. Is 1 less than 4? Yeah, it is. Do stuff. Do more stuff. Add 1. Now x is 2. X is less than 4 because 2 is less than 4. Do stuff. Do more stuff. Add 1. Now x is 3. You getting it? Now we get to a point where we get x is 4. This is no longer true because 4 is not less than 4. 4 is equal to 4. So it checks it. It goes, okay, you know what? 4 is equal to 4. It's not less than 4, though. So skip everything here and move on to the next thing. And now we're doing other stuff. So that's the key part of the while loop, is as long as the stuff inside of the parentheses is true, you don't have to have parentheses, as evidenced by here. As long as the stuff, you can just imagine parentheses in your head, though. That always works. As long as the stuff in parentheses is true, the while loop will continue to execute at least one more time. The minute that it's false, the minute that this is false inside of the parentheses, the while loop aborts. It does not run. It runs exactly 0 more times, and it skips to everything after the while loop. So that brings up the question, when is true true? This is not a trick question. When is true true? Almost, except the opposite. Yeah, it's well, when it coincides with what you told it was true. Okay, so that's an interesting point. So here's the thing, though. Oh, for sure, Harry. Um, Here's the thing, though. So when we call true, that's actually just a value that's built into Python. It literally just means true. So in this context, if we type in the word true verbatim, it's always, 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 always going to evaluate to be true. Always and forever. So what we've done here is we've created a loop that runs forever, while still following the logic of the code. This is a completely intentional forever loop. Because as long as planets orbit the stars, as long as entropy exists, as long as time moves in a forward direction, true is always going to evaluate to true. As long as computers exist, and as long as their CPUs aren't borked beyond repair, true is always going to evaluate to true. So this loop will always run forever. So if we left this computer running until, you know, there was no longer any power supplied to it, or the hardware failed on it, or whatever, this loop would continually run. Now, obviously, it stops because the program that they've written in the backend stops it before it runs forever, because all it does is it checks it to a certain point and it goes, okay, you're cool. But like if we wrote our own Python program that ran while true, it would never stop running. Never, ever, ever, ever. Until, well, there are always exceptions to the rules in computer science and stuff like that, which is part of the reason why I hate saying always and then right after it saying, except in these situations. But that's kind of how it goes with computer science. Is there are always exceptions to the rule, except when there are exceptions to the rule. Man, really doesn't help when I say that. But just for now, assume when I say always that it's the rule. And that somewhere in there is an exception that you'll probably run into later on, but with the understanding that it's meant to subvert the rule so that you can do something a little bit more complex than the rule provides. And that's kind of the beauty of computer science, is that it's about taking these rules and combining them in logical ways and using exceptions, tactically and stuff like that in order to create a very complex set of behaviors from a computer. That's coding in a nutshell. is you take simple stuff like building blocks and you stick them all together in order to make it do more complex stuff. And all we're doing right now is we're giving you the simple blocks so that you guys can use those blocks to build upon and make the more complex stuff. So anyway, those are while loops. Now it's important to note that these while loops run forever, but once you get more comfortable with variables and how a computer handles them and math and stuff like that, which we will in subsequent ones here, you will understand how to make loops that terminate after a certain number of times. But we'll get there. So that's this level. We got a new item. It's a bird. It's been a while since I've started up CodeCombat. I don't know why you got a bird. I guess we'll see. Used to not get a bird. So the second Kith maze. Many have tried, few have found their way through this maze. So this is going to continue. It's a subscriber only thing. All right, well, we don't want a bird anyway. Bird's stupid bird. Get out of here. Continue Python. So this is going to be another forever loop if this level is the same as the last time I used this program. Sure enough, it is. So now we're going to think about how we can repeat our code. Obviously, this is not correct because she keeps running forward into the spikes and eventually kicks the can, kicks the bucket. What we need to do is we need to set up this loop so that there is a repeated behavior that allows her to navigate through this. So let's just try this. Let's try hero.moveRight, and then after that she needs to move up, right? So let's hero.moveUp. We'll hero.moveRight again, and hero.moveDown. So now, move right, move up, move right, move down. So far, so good, right? Do you think I need more commands? Let's just. Am I short any commands? Is there anything else that I need? No? All right, so we got a no with a question mark. All right, all right. Can anybody give me does anybody have any more confident answers? Not to say that you were, you know, I'll make you feel bad about that or anything. That wasn't my intention. Just run through, close it off. Okay, so you're saying that it's good to go. It's done. Oh, gotcha. All right, fair enough. So you already know. Okay. Yeah, no, that's all we need. Because as soon as we get down here, we hit the top of the loop again, right? And so the hero moves right. All right, look at that. Perfect. Then the hero moves up. Perfect. The hero moves right again. Perfect. Then the hero moves down. All right. And then it repeats over and over again. So yeah, this is meant to help you think think about loops more too. Again, this is not introducing any new concepts. This is still just a forever loop, a while true, also known as a while true loop, and moving the hero. Literally everything you've done in previous levels, except now you need to sort of stretch your mind a little bit and get used to thinking in terms of loops. So we'll go ahead and hit run and test it out. Going, 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 going. And so far, that looks pretty promising. Sure enough, navigated through it. So when you say you've already done this whole thing twice, do you mean you've done like all of the first world in CodeCombat or just this level? Like everything up to this level? Well, either way, hopefully, if you've done the entire world, if you've done, subsequent worlds or something like that, there might be something that you might find enlightening in here. I hope. We shall see. All right, so we got a wolf pup and a faux fur hat. Let's not show the fur hat to the wolf pup. But granted, I'm assuming that the wolf pup is going to be a subscriber only pet. Yep, sure enough. That is a sweet hat. Wicked, wicked hat. All right. Your hero must survive, and you must defeat the 3 ogres. Declare a variable like this. When you use quotes, you are making a string. When you don't use quotes, you are referencing the variable. Okay, so we're going to... Wow, all right, so they're introducing us to variables. Cool. All right, so variables. Variables are pretty pretty straightforward, but sometimes, like, initially, like, it can take a moment to wrap your head around the concept, because that's just sort of how all of programming goes. It's actually really at its base, it can be pretty simple, but it can always take a minute for you to wrap your head around the concept until you finally just grok it, and then you go, oh yeah, duh, okay. And you just have to think of it in a context that makes sense to you. So one of the contexts in which I explain variables is it's like a box to hold stuff. Yeah, and I shouldn't even have to do that now that I think about it, because you guys have gone through algebra. So you're used to y equals x plus 5 and solving for y given certain values of x and stuff like that. So you know about the idea behind variables. You know that variables are simply a reference to a value that you don't necessarily know. Or I guess they're a mutable value. Computer science variables, programming variables, are that concept just expanded upon. Let's say, you had this y equals x plus 1 thing. Well, yeah, these would technically be variables in programming. But the idea behind these programming variables is that you can use them elsewhere in the program. You can call back and reference them by name, and whatever values they're holding, you can then use those to do math on them and stuff like that, or throw them up on the screen, or yeah, like substitution rule and geometry proofs. Yeah. It is literally substitution. It's substitution so our feeble human minds can better understand where something goes in a computer. I say that with the utmost respect and reverence for the human mind, since it made computers in the first place. But referencing something by name allows you to use it in so many different places in your program. Granted, you probably don't want to use it in too many places, but that's more of a programming sort of etiquette kind of a thing, which you don't have to worry about now. But you can use it in so many places in your program. You can reference it later. You can do all sorts of crazy math to it in a function way over here, and then bring it back, and suddenly it has a different value in it, and then you can use it back over here, and blah blah blah. Anyway, one of the best ways to understand what exactly a variable is good for is to use it. So that's what we're going to do here. We're going to use these enemy variables. Now, all these they are names for spots in memory that are meant to hold values. In this case, there is a spot in memory reserved specifically for this. Anytime we want to refer to it in the code, we refer to enemy2. This specific spot in memory contains the word Gert. Just like this specific spot in memory, referred to as enemy1, contains the word Krat. Now it's important to note that, yeah, it's like the substitution rule. Anytime you're looking at a variable in your head, you can substitute it with the value it contains. So doing this hero attack enemy 1, It's the same thing as saying hero attack Krat. It's going to yell at me because it doesn't want me to do that. But we're doing exactly the same thing here because this enemy 1 represents that. So we can say hero attack enemy 2, hero dot attack enemy 2, and hero dot attack enemy 3, and hero dot attack enemy 3. Boom. And like that, now we're referencing Krat, Gert, and Ursa in order. If we wanted to, we could do enemy 3, and enemy 3, and enemy 2, and enemy 2. And then we're referencing Krat, Ursa, and Gert. You know, it's all we're doing is we're just talking about what's contained in that spot in memory, and we're referencing that spot in memory by name. Here, you bring up an excellent question. So, could you use a while true loop? Almost. Almost. Because I get where you're going with that. So if we did like a while true, then we could do hero dot attack and hero dot attack, and then we could have 2 sets of commands, right? Instead of 6, and that would reduce the amount of typing that we had to do, right? But here's the tricky bit. Oh, whoops, enemy 1. Not attack 1, enemy 1. So let's say we run that loop. Unfortunately, all our hero is going to be doing over and over again is attacking enemy 1. Now, some of the more ambitious ones out of you guys might say, well, wait. Huh? Ooh, I see what you're saying. You bring up an interesting point. So what if we did we could do this, and each enemy will certainly be attacked twice, because the loop will be guaranteed to run twice. And sure enough, yeah. Oh, yeah, no, excellent call there. Excellent call. Man, you bring up another thing that's great about programming is there are a jillion different solutions to a given problem. And there are ones that you'll think of that I'll never think of in a million years. And there are ones that I'll think of and you'll be like, what? That makes perfect sense, but I didn't even think of it that way, you know? It is some of the most open-ended puzzle solving that we've created, and it's fantastic for that. Now, that also can be its downfall, because then you can run into situations where like you're looking at this code and you're like, I have no idea what's happening. And technically you solve the problem, but like, oh my God, you use so much memory and it runs for an extra, 3,000 cycles, and it calls 15 different methods that are totally useless. Not saying that's what's happening here. I'm just saying, like, as programs get more complex, you can run into that situation, because the question of programming something, of solving a programming puzzle, is such an open-ended one. So you can run into situations like that where there are suboptimal solutions. This is not one of those. But that's the thing. For any suboptimal solution, there are just as many optimal solutions. And arguably, there are 50 billion subjectively optimal solutions. That is to say, one person will think it's a better solution than somebody else, and that's where you get 99% of the programming arguments that exist on the internet. Yeah, no, good call there, Harry. That's awesome. So this is another way you can do it, and you reduce the number of lines of code that you have to type. So now we're going to get a cat and some sunglasses. A cougar, oh, sorry, and nerd glasses. That's okay. All right, so boom, master of names. All right, so here's where the glasses come into play. The glasses actually introduce us to our first method that returns a value. So you'll notice enemy one right now is equal to hero.find nearest enemy. Well, that's curious. It's not Ugh or Brock or Snarg or whatever. It's a command. What does that mean? Are we literally storing a command inside of a variable? Well, yes and no. I think it's time I introduced you guys to what exactly these are. So for now, we're going to pay attention to everything that's after the period on each line. We're going to ignore the hero dot, and we're just going to look at everything that comes after the period. Because what is that stuff? Well, it's called a method, or it's called a function, depending upon what language you're most comfortable with. And then a method or a function always takes the form of name and arguments? Just like that. So you've got the name of the function, and then you got some parentheses, and you might have something inside of the parentheses. Notice how find nearest enemy doesn't have anything inside the parentheses. However, attack does, just like I was saying before. So methods or functions allow you to and I'm going to try and explain this as quickly as possible because I know we're running low on time. So this might get a little bit rushed. They allow you to repeat common bits of code, much like a loop. However, you have a lot more control over how often you run it. And you have the ability to send information to it and get information back from it. So let's say, well, let me put it this way. A method is nothing but a collection of of commands. This bit of code right over here, this is technically a method. We can make this a method. But let's expand upon our concept of variables and methods with a really simple thing. Let's say we have a variable x, and x is equal to 3. And let's say we have a variable y, which is equal to 2. And let's say we have a variable z, which is equal to... We'll get back to that. Now let's say we've created a method called add. Now the guts of a method, like I said, are simply nothing more than a set of commands. So we can say return x plus y. And that'll be our command. All we're doing is we're sending back the value of x plus y. So now we can say z equals add. We're not 100% there yet, though. See, unfortunately, let's actually rename these in order to clarify things a little bit. So when you enter in a method, with some exceptions, a computer will tend to forget the variables that it was holding on to earlier. This is not exactly a 100% accurate description of what's happening, but it requires a discussion about variable scope, which is something that you guys don't really need to know right now, but you will need to know later. But suffice it to say, when we get into add doesn't know what x and y are. That's why I renamed them to A and B, so that we didn't get confused. However, this is where arguments come in, because arguments allow us to feed variables, good Lord, into a function or a method so that it can use those variables. So if we say add A, comma B, what's happening here is x is equal to 3. Boom, we got that. We put it in the box. It's good to go. Y is equal to 2. Boom, we got that. We put that one in that box. It's good to go. Now we're going to say z is equal to add, the result of add. However, we're going to send to it x and y. And then it's going to go, hey, where's add? And then it finds add and it goes, oh, add's right here. Okay, so now add needs two variables. Inside of add, we're going to call them A and B. Cool. Well, it's going to feed those values in. Boom, 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 boom. And it's going to say, okay, so A is going to have, well, let's follow back the chain, 3. And B is going to have, let's follow back the chain, 2. Cool. So now this is going to be return 3 plus 2. And it's going to say, okay, so we're going to return that value. All right, send it back to Z. And so we're going to just stick the value 5 into Z. So you can think of this as like a replacement for a specific value. So whereas x is equal to 3, oh god, now I've started writing with the pen, and y is equal to 2, what we've essentially just said is z is equal to x plus y. But we've done it in a computery way with a method. Why would you do this as opposed to just z is equal to x plus y? Why would you waste your time with that? Well, let's say our program does a lot of adding of stuff. We might also have, let's erase all our drawings. We might also have, f equals 6 and g equals 9, and we want to find the value for h. Well, we can go, oh, hey, add f and g. And as our add function gets more complex, maybe we have, a equals a divided by 2, b equals b times 5, c equals b times a, and then we return a plus c times b. Suddenly our math gets a lot more complex there. And it doesn't become an add function anymore. But if we ever wanted to perform this set of calculations on something, or this set of math on something every time, well, we'd have to, okay, so, all right, replace all of this. Cool. And then z is going to be equal to that. And then if we wanted to get h, then we'd have to do that for h as well, and that would just, it's not ideal. Z equals add f or x, y. So methods give us the ability to expand upon the functionality of our code without drastically increasing the amount of typing we have to do. So this find nearest enemy function, what that does is that literally finds the nearest enemy and gets its name. It returns its name and then feeds it into enemy 1. Then we tell the hero to attack enemy 1. The end result of this is our hero finds the enemy name and attacks the enemy without us ever actually knowing what the enemy's name is. All of that stuff is completely hidden from us. It's kind of interesting, right? And see, that's the thing. we could write all of this stuff ourselves and tell the computer to pass this information between a whole bunch of different stuff. So we could have written find nearest enemy, and we could have written attack, and then we could have written a generator which generates orcs with random names and stuff like that. And this still works. This will still dutifully find their name and attack them without us personally having to know their name and put it in manually. So I think it's pretty clever. Anyway, we're going to run it. So find nearest enemy, boom. Finds the second enemy, boom. We don't set it up for the third enemy though, so we have to do that. Enemy 3 equals hero dot find nearest enemy. And anytime it starts to do that, so like see how I start typing and then I get like the little drop down menu, you can just press enter to autocomplete it. So enemy 3 hero dot attack enemy 3, and we're good to go. Now to expand upon the point before, we could actually throw all of this in a while true loop. You ready for this? Tab, tab, tab. And now we'll run it. Now look at that. She finds the enemies and she gets rid of them. That's because we can always overwrite the values inside of a variable at any given time. So all we're doing is we start out with one enemy name the first time we run this. Then we kill it. Whoops. Then we run it again and we find a second enemy name, and then we just simply replace the value in enemy 1 with the second enemy name. In fact, we could just call this enemy in order to remove some of the confusion, and it would still run just the same. It would run just as well. So that allows us to use our previous knowledge in order to expand upon this and get a little bit more efficient with our typing as well. And that's the whole idea behind programming, is taking these blocks of logic and combining them in creative ways in order to solve the issue you're looking for. Oh, nice. You do like an inspect thing and just say like, let's see here. Yeah. Yeah, well, at some point. But yeah, if you manage to do that, they probably actually put that in the code so that you can if you want to. Just because when you get to that point, you're obviously a much better programmer. But anyway, that's pretty awesome. We're going to go ahead and call it a class for today. So I'm going to do the poll questions. Then we're going to leave it open for question and answer time. If you have any questions about anything we went over today or anything else, doesn't even have to be related to the lesson, we can go over that. Otherwise, after we're done with the poll questions, you're more than welcome to head out. Have a wonderful weekend, and you will see Mr. Dubik on Monday, and you will see me on Wednesday.